Yeah. Yeah. Good afternoon, everyone.
Good afternoon, sir.
Yeah, I want to welcome you to. I want to welcome you. Some people are making noise. So please, those who are, mute yourself so that we can be able to go on together. Now, yeah, today we want to look at start 111. Okay, and the course is descriptive statistics. Descriptive statistics. So it's the basic statistics we teach in the department. And from what I see now, we have students from statistics department. We have students from computer science. Do we have any other person from outside these two departments? Do we have people from mathematics or any other department?
Physics department.
Okay, you have physics department.
Data
Okay.
science, sir. Data science.
You're under statistics. So any other department apart from these three, statistics, physics? Yeah, I've mentioned computer science. Statistics, computer science, physics, data science is under statistics. I'm talking of department, not course now. Okay, so basically I could say I have about 3 departments presently doing the course. I've not seen anybody from mathematics, so I wouldn't know if it's compulsory for them, whatever is the case. So we will start today. Just to do a little bit of troubleshooting. When is your exam? Do you know?
April, sir.
April when?
So the time is not yet on.
Timetable is not out yet.
Yeah, the timetable is out. So April what? April what?
Not out yet.
It's out, oh. It's
I just
out,
said,
oh.
yes,
Your
it's out, but I don't know. I just said it's April.
They just said what?
The timetable is out, but I didn't know. I didn't know when we are starting, but the exam is April.
It's April. I can't remember the date now, but I know it's April. Now, that means that we have to finish our classes between now and the ending of March. Is that not? So,
Yes.
and that
Yes,
and
sir.
that and that will mean that because we are 2 of us taking this course, myself, I am Professor M.O. Adamu, the former HOD of the Department of Statistics, and my other colleague that will be taking it with me is Dr. Badmos. So basically, I may take you for the month of February, and then maybe he will now take you for the month of March. So that's the way I think we are going to do it. So this month is going. Today is 11th. So basically, I would say maybe I have about 3 weeks with you to go through what I'm supposed to go through. Then he will now come up and do his own part. So basically, we are going to look at this course. To me, it's a 3-unit course, but at the same time, I feel the course contents are not too loaded. We all can benefit or from it. And I also know that I also know that these things we are going to do, most of you, or if not everybody, have done them one way or the other. You just entered the university, you are in year one. So basically, you must have done statistics in your secondary school. So basically, many of the things we are going to do in this course, except for a few of them, you have one way or the other come across them while you are being taught in your secondary school. So, but now what we want to do here is to expand what you may have known or you were taught, expand it to the points that you can get a deeper knowledge and understanding of what you need to know. So I am sharing a slide of a textbook which we are going to be using in the department, which we have. So I will encourage everybody, you can go to the bookshop and get a copy of the textbook. The title is A First Course in Statistics. A First Course in Statistics. So you can go to the bookshop and then get a copy of the textbook. Now, we have this class between the hours of 2 and 4 every week on Tuesday. So please, let's spread the message out. I want to believe that mathematics is supposed to do this course. I'm not sure, but I want to believe they are supposed to do this course. So if you have colleagues that you think are in mathematics that are not here, please, you can help us reach them so that they would be aware of the class and partake in whatever we are doing. So in this course, from the course content I have before me, which I am going to mention now. Okay. I have for start 111. We have the course content, statistical data, types of data, sources of data, and methods of collection. We are going to look at presentation of data, tables, charts and graphs, errors and approximations, frequency and cumulative distributions, measures of location, partition, dispersion, skewness, and kurtosis, rates, ratios, and index numbers. Now, these are the things we want to consider in this course. So we are going to start now by trying to understand the intro of what we want to do. Now, we are talking about statistics. Statistics is the science of collecting, classifying, presenting, and interpreting data. And if you take each of those terms I mentioned now, they all have their various meaning. For number one, you collect data. When you talk about science, you are talking about doing something that can be proven, that can be tested, and you can have results that can be verified and results that are consistent. Now, we talk about statistics as a science of collecting. So when you talk about statistics and you are collecting data, for example, you want to collect the names, the matric numbers, the addresses, phone numbers of the students in your class. That process of you collecting those information can be termed as statistics. So it's a science of collecting of data. When you collect data and in various forms, sometimes you can collect data manually by asking questions. You can collect data by giving people questionnaires to fill, and then they fill those questionnaires for you, and then you begin to uh, extract whatever they may have filled in the questionnaire. Sometimes you're going to, let's say, the Third Mainland Bridge, and then you are counting the number of Toyota cars that are applying the Third Mainland Bridge. That process of you collecting that information or that data can also be said to be statistics. When we talk about classifying data, you can put data in various forms, which we are going to see later now. Talk about different types of data. We have to classify them. Even these days of, we call it big data, where you have streams of data coming in microseconds and they are coming in rapid successions, like your Twitter, your Instagram posts, even TikTok, and things are being posted. In a day, you'll be talking about millions of posts. Now, all these posts are all data that can be pulled out and used for analysis. It can be pulled out to do a lot of things, do some classification. You can classify the data, whether they are categorical, whether they are numerical, and then you can put the data in various forms. And in this period of AI now, we talk about data. We have what we talk about when we talk about the natural language processing, where you talk about languages, you talk about words, you talk about linguistics and things like that. And you may be collecting data also in that form. That is also data. And in the era of big data now and machine learning and AI, you talk about data. Of course, when you collect this, there are different types. You can classify them, okay, in different form and in different shades. So statistics is classifying. You can classify them. Some data in pictorial form, pictures now, images, are also data that are used for analysis and for other things. Okay, so we can talk about classifying, talk about collecting, talk about classifying, presenting. In this aspect of statistics, as an individual, you can go out, or perhaps in your environment, you notice some things. Just in your streets, you can just notice, the way the houses are arranged, there are some things about them. You may just collect information about the houses on your streets, and then you want to do some presentation, okay? It's possible you want to say, okay, in a compound, how many people do we have in each compound? Okay, you might say, okay, in house number 1, we have about 15 people living there. In house number 2, we have about 12 people living there. In house number 3, we have, you can just gather those information from your streets, and then so how can this data I've collected, how can I make meaning of it? How can I talk to people about it? What can I do so that people will understand what I am doing? And then you now be looking at what ways can I apply to show people the data I've collected. Okay, and I may want to now show it in a form. It could be like in a table. That's how I want to put it. It could be in a pictorial form. Okay, as some of these pictorial form, you can be talking about okay, I want to do a bar chart of different houses. How many houses have 10 people living in it? How many people have 15 people living in it? How many houses having 5 people living in it? You want to show us a picture of how it looks like, or a table of what it is all about. So when you're able to gather large sums of data that will not make any meaning to anybody, okay, you now want to put it in a concise form, put it in a form that people will appreciate and people will be able to key in and flow in with. So you are presenting. So that process of you presenting the data you have collected for people to understand and appreciate is also statistics. So we've looked at collecting, we've looked at classifying, we've looked at presenting of data, and we are going to see that there are different ways, and we cannot even exhaust them all. There are many other ways that you can use statistics to present your data for people to see what is going on. Now, we also talk about interpreting data. If you talk about interpreting of data, what are we talking about? For example, let's say in your class, you are the class rep, and then they give an assignment. And in that assignment, maybe about 30 or so of you in the class, they give the assignments, they mark those scripts and give them back to you as governor. And then you are asked to collate everything, tabulate everything in a table or something, and let's know. The lecturer say, please find out what's the average performance in that test. Now, if you want to do that, what you need to do is possibly maybe you write their name, their matric number, and the score. And then you have those tables for everybody. If they are 30, fine. If they are up to 100, it will be very difficult to comprehend what is going on. What you now have to do is to say, okay, let me find the average performance over 30 in the test. What did they score? So what you need to do is to add the score of everybody in that class and divide by the number of people that wrote that test. That will give you the average. Now, that average you got, you can now say, in the test, so the average performance was around, let's say, 16 over 30. So that means averagely, the performance of the class is around 16 over 30. That's, you are interpreting the data. You are giving meaning to the data. You are able to say something about the data. Like the one I made mention of now, like on the streets now, let's assume that you have up to about 50 houses there, and you are able to know how many people are staying in each of them, and then you find, okay, how many people all together are staying on these streets, divided by 50, the number of houses we have there. Perhaps maybe when you divided, you got 6. So you can say averagely on my street, there are about 6 people per household living in each compound. You have interpreted that data. That's interpreting of data. That's statistics. So you see that statistics is the science of collecting, classifying, presenting, and interpreting data. And you will agree with me that our society has developed into where science and technology affects virtually everything around us. Statistics is one of the most important of these statistic tools, scientific tools that you can use virtually in any field, and every field you would have the need of the use of statistics. Even with the advent of AI, with the advent of machine learning, you cannot do without statistics, because many of the parameters and the metrics that are being used to analyze natural language models, to analyze different models, they are all statistics. So you would need statistics in virtually almost any field, whether in education, whether in business administration, whether in environmental sciences, whether it's even in linguistic that they speak language, they need the use and the knowledge of statistics. So you cannot talk about any field, any scientific thing, or not even scientific things, that you want to do that you do not need statistics. It's very important, and it's one of the most important tools that you will need to work on. In fact, if you are doing any research, any analysis, if you don't have statistical tools implemented or used in analyzing those stuff, in many cases than not, those results will not be termed accurate or legal or useful, as the case may be. So that's why you need this scientific tool, which is a science, like statistics, to be able to verify whatever you are doing and give a basis and fact to what you may be doing. And as I've mentioned, there are so many areas, business, engineering, political science, economics, psychology, sociology, just name them. You cannot work in those areas if you want to do a solid work that people would count on. You need statistics to be able to effectively pass your message to people. Now, statistics is a universal language of the sciences. Statistics is more than just a kit of tools that we use to do some things. As the potential users of statistics that you are now, that you are learning this, you need to master this art of using these tools correctly. Now, we need to know that there are statistical methods that we employ that enable us to do 3 things. Number one, it makes us to accurately describe the findings of scientific research. Any scientific research you may be doing in any field, that's why you see these days, virtually almost every field will ask their student to go and learn a good bit of statistics, because you cannot do without, if you are doing research and you want to describe your findings, and you just must have to use statistics in doing your findings or describing the findings of your results or research. Number two, the statistical methods that we have can help us to make decisions. Yes, to make decisions. For example, I know from data that is flowing maybe online that people are complaining about a network, a social telecom network, and this is complaining that. When people gather those data from people or clients, or when you have the customer service, they gather data from you of your complaint. From there, when they analyze the data, it will help them to know what people are talking about, what the issues are, and this one will help them to make decisions. Okay, if there is a clog somewhere in the system, oh, people are complaining about this, they will go there and fix the thing. So they can take quick decisions once they use some of these statistical tools to analyze their data, and they can make decisions very fast. Number 3, you can also make estimations by the use of statistics. For those who are doing stock exchange, for example, they can estimate with the use of statistics. Okay, we noticed that the dollar was this yesterday, dollar was this 2 days ago, dollar was this so days ago. We can use statistics to model and estimate, what is most likely going to happen this week, Wednesday, Thursday, Friday. What will be the value of the dollar? With the use of statistics, you can make estimations. We can estimate, okay, dollar is going to be 1,000 so and so by Wednesday from our findings. You can estimate not only in dollar, other things that we need some projection and estimation. You can effectively use statistics to do that. I will pause a little and then give room for questions. If you have any questions to ask based on what I've said so far, please, you can unmute yourself and ask your question.
Good afternoon, sir.
Yeah, good afternoon.
Sir, please, can you repeat the course outline? Some of us didn't get it.
Okay.
Thank you, sir.
Maybe I'll do that
Also,
later so I'm not to. Yes.
sir, please, can you name of the textbook again?
A first course in statistics. A first course in statistics. Yeah, any other question based on what we have done? Any question?
No questions.
Okay, so we would go on with what we are doing. So, as I said, now, statistics is roughly divided into 2 areas. Roughly divided into 2 areas. And we have one as the descriptive statistics. Then the other one is what we call inferential statistics. And these 2 areas are going to be talked about. This course that we are doing now is a descriptive statistics course. There is another one, 121. That one, they call it inferential. That one you are going to learn is inferential statistics. Okay, which the other, I believe, is starting this week also with you. So, but we are looking at the descriptive statistics in this course, but though I can tell you categorically that whatever we even do is not sufficient, or it will not give you a complete nutshell of what it is all about, because there are many other things. But at least you have a good intro into what descriptive statistics are, and then good examples, and then we'll use some tools in that area. Similarly, also for the inferential statistics, what you are going to learn in 121 is just more of more of an intro, and will help you to understand the basic things you need to know about inferential statistics. Again, inferential statistics develops into more higher complex statistical tools, but these two courses are more of an intro to you. Okay, so when we talk about descriptive statistics, this is what most people think about when they hear the word statistics, because that's what most people observe or see easily. And this includes, I mentioned collecting, presentation, and description of data. Okay, that's what most people think of when they hear about the word descriptive statistics. And as the word implies, describe. You collect your data, you present it, you describe how it looks like and all that. You don't do much of any analysis or anything. Just present it in diagram or in tables or in charts, in presentations and all that, even in charts and all that, for people to see and appreciate. That's descriptive statistics. But when we talk about inferential statistics, we're talking about the technique of interpreting the values resulting from the descriptive techniques, and then we now use them to make decisions and draw conclusions about a sample or a data set or population or whatever you want to make your decision on. So when we talk about inferential statistics, it's about going deeper beyond descriptive techniques and then using them to make analysis and testing, and then you now draw conclusions and you make decisions, okay, as to what the data is all about and what you will gain from such data. Now, in statistics, we have some terms. If you are starting a new team, for example, they will tell you their language term. There will be some basic terms they use more often. So these terms, when you hear them, they are talking about this. When you hear this term, they are talking about that. So in statistics, there are some basic terms we use, which you need to know what they are, what they mean, and how they can be applied. Now, the simple terms we have here: population, sample, variables. We talk about, is it here we talk about probability? No. We talk about data. Okay, we talk about statistic. Take note of the word statistics, not statistics, no S there. What does it mean? We are going to look at that. We are going to talk about experiment. So we are going to talk about these, okay, as we go on. So let's go back and talk about population. Now, I will need to explain what population is to you, because in statistics, when I mention population, what do you think about? Okay, you'll be thinking about, the population of Nigeria. Fine. But in statistics, what does it mean? You'll be hearing sample. You'll be hearing sample. What do they mean in statistics? What does it mean in statistics? You may have even been hearing variable. In statistics, what does it mean? We need to look at each of these and know how or what they mean, so that when we are using them as we go along, you will know what they are. Okay, what is a population? It's a collection or set of individuals or objects whose properties are to be analyzed. I will explain. You see, the concept of a population is the most fundamental idea in statistics. Very, very important. The population of concern must be carefully defined. Carefully defined. I say it again. When we say population, if you don't get the meaning and the understanding of it along the line when we go on, and even in other courses as it relates to statistics, if you do not understand the principle or the word population in statistics, you are going to mix up a lot of things. But so please listen carefully as I try to explain to you what population is all about. Now, this is fully considered only when its membership list of elements is specified. The set of all students who take algebra course in year 2 is an example of a well-defined population. Please listen very well. The set of all students who take algebra course in year 2 is a population. That means that all students who are taking the algebra course in year 2 are members of that class or members of that set. So we call that a population. Another example is the set of all lecturers in University of Lagos. When I say the set of all lecturers in University of, it's also a population. That is, everybody who is a lecturer in Unilag is in that set. So when you talk about population, with the mindset, what is the population of Nigeria? It means everybody that is a Nigerian is in that set. We call that a population. This is the concept that everything that that set represents, everything that you have in that set, complete, makes it a population. Because you know why I'm saying all this? We're talking about population. We are going to talk about sample after this. Population and sample are similar. When I say a sample, when I say a population, they are similar, but they are not the same. They are not the same. They are similar, very similar, and can be very confusing to people if you don't understand the principle around the two of them, but they are different. So when we talk about population, we are talking about everything possible in a set. Now, for example, the set of all statistics students in year 1 is also a population. The set of all statistics students doing this course in year 1 is a population. So if I get all the students in year 1 in the Department of Statistics, they will all be in that set. That's a population. The set of all those doing start 111 is a population. That is, everybody doing the course start 111 are all members of that set. So I will call that set a population. Sometimes you may be doing some research or collect data, or collect sample, you need to know the data I collected, is it a population or not? Because later on, when we are going to see, you will see that the formula you use for population is different. The formula you use for sample is different. The symbols we use to represent population is different. The symbol you use to represent sample is also different. Very, very important. Please understand these two different things so that when you get to know a data, you know whether it's a population or a sample. Now, population involves not only people, but also a collection of animals, manufactured objects, or anything. It's not just only human beings. And there are two types of population. You have a finite and infinite population. When you talk about finite, these are countable sets. Okay. Population of students in the Department of Computer Science is finite. Okay. The other thing is what could be infinite. I want to count the number of sands that we have at the lagoon front of Unilag. Could be infinite. Counting it, you will count forever. Could be said to be infinite. So when you have data, there are data that are finite, there are data that are infinite. Where the population of Nigeria is finite, you can calculate it. Okay. So, and then you have some other objects also that are infinite. Now, the infinite, when the membership is uncountable, I've explained that. The number of students in University of Lagos is a finite population. You agree with me, it's countable. The set of all registered voters in Nigeria is a very large, but it's finite, a finite population. On the other hand, the populations of all the stars in the sky is infinite. The population of all the sands at the seashore all over the world is also infinite. So we understand the principle of population. Now, let's talk about the other part called sample. Now, when we talk about sample, please look at the definition. A sample is a subset of a population. When I say a subset, it's a part of a population. It's a small section of a population. A sample is not the same as population, but they are very similar because they are collecting the same data and they have the same data. For a sample does not have all the population. It's a part of the population. For example, when you say a subset consists of the individuals, or okay, let me use, for example, now, the population of Nigeria. If I now say, what is the population of Lagos State? That will mean you will get everybody in Lagos State. That is a population. But that population can become a sample if you are talking about Nigeria. So the data of the population of Lagos citizens will become a sample when you are talking about the population of Nigeria, because Lagos is a subset of the entire population of Nigeria. So that data that you said, the population of Lagos State that was population, will now become a sample when you are talking about the population of Nigeria. I don't know if you are getting the gist I'm trying to say. It's a subset. A sample is a subset of a population. Please remember, I said earlier on, the population of statistics, Department of Statistics students doing this course, that's a population. That's everybody in the Department of Statistics. But you know, in the Department of Statistics, they have those doing statistics as a program. They have those doing data science. They have those doing biostatistics. They have 3 programs under that. But if I pick those doing data science in statistics, it now becomes a sample of the population of those from Department of Statistics, because it's a part of that population. The population is the Department of Statistics. The sample is now data science separate, biostatistics separate, statistics separate. So each of these units are said to be sample of the population Department of Statistics. So if I pick any of them, I'm dealing with a sample. Now, and I can go up and up and up. I pick the Department of Statistics, for example. And you remember I mentioned the population of those doing Stat 111 is a population. And then I ask, was it those from the Department of Statistics? Department of Statistics that has 3 units is a subset of those doing Stat 111. So Department of Statistics is a sample of the population of those doing Stat 111. Are you following me? The department that was a population now has now become a sample under a bigger umbrella. It's like you have an umbrella, a smaller umbrella, a more bigger umbrella on top, another more bigger umbrella on top, another more bigger umbrella on top. So each of them becoming sample of the next preceding higher umbrella. So you can step up like that. And then you have a sample that's a part of a population. Now, you see, I talked about the population of Stat 111. That's everybody doing Stat 111. That's a population. But if I'm talking about the population of year 1 students in Faculty of Science, that those who are doing that course, they are all under that Faculty of Science. They are a part. So that's my Stat 111 course that was population now becomes a sample under the Faculty of Science because there are many other courses. Are you getting what I'm saying? So a sample is always a subset of a population. So we need to understand that, and then you can look at all the examples we have there, but I've explained all that. Any question on what I have said so far? If you have any questions to ask, you can please signify by unmuting yourself and coming up to answer. Okay, in the absence of no question, it's assumed that everybody understood what I've been saying all along.
I have a question.
Okay, go on, Taiwo.
Sir, from that your example about Faculty of Science, once it's already, let's say, in the old school now, can the Faculty of Science later become a sample?
Yeah.
Then if you now say,
Yes, it can become a sample. If you're not talking about the whole university now, that Faculty of Science is a sample, a subset of the population of University of Lagos. If you're not talking of University of Lagos in Nigeria, University of Lagos will now become what?
a sample again.
Yeah, of the entire university outside. You understand? Okay.
Thanks, sir.
Thank you. Any other question? Okay, so that's taken and understood. Now, when we talk about...
Sir, I have a question, sir.
Okay, David.
Yeah, I want to ask, is it possible to have a sample of a sample?
Well, maybe, yes, it's possible. And when you are doing research, actually, you want to pick a sample from a sample. For example, I have Lagos State, maybe as a population, and then I want to do, pass out questionnaires to people. Okay. The people I can reach sample because I cannot reach everybody. So, but out of those sample I'm able to reach, let's say, for example, University of Lagos, I want to disable questionnaire. I cannot get the entire population. So it's a sample I will see. And out of those sample, I can now pick from that sample, okay, I want to give 100 people out of 500 people I can see. You are picking a sample from a sample, okay? Which later on, if you go along, you'll be talking about small n. What's the sample size you must pick from a sample to make it worthwhile? Yes, it's possible. Okay, so let's go on and let's talk about a variable. What is a variable? A variable is a characteristic of interest about each individual element of a population or sample. Take note, population or sample, because later on your data may be population, your data may be sample. You can still use either of them to do whatever you want to do. Okay, so a population or a sample, for example, a student's name. Sometimes they ask you to collect information of the students in your department as maybe as a rep or something. And then you say, okay, I want to collect the details of what everybody in my department. Please write your name, your matric number, your phone number, the course you are doing, or the program you are doing. If you are in statistics, for example, you are doing statistics, you are doing biostatistics, you are doing data science, write the course and things like that. Each of those columns that you are getting information on every person is called a variable. When we say variable, is something that changes, something variable that changes. So if I have the name, it's a variable because somebody is David, somebody is Lasisi, somebody is Isa, somebody is Abdullahi, and so on. So the names are changing. So that name is a variable. So if you have a name that gives you all the names of the people, you have the matric number, they are different and unique to every person. That's a variable. You have the course they are doing. It's also a variable. They tell you whether they are doing data science or computer, or they are doing biostatistics or whatever. You list them down. Okay, you have things like that. So you can have variable that describes your sample. So there are characteristics of interest about each individual element of a population or a sample. Okay, that's clear. Now, we talk about data. Well, when you say data, what comes to your mind is statistics. But what is data? From what we know. Now, data are raw facts or unprocessed information. Unprocessed information. There are basically two types of data. There are two types of data. And data, as I said, are raw facts or unprocessed information that are gotten. I will explain that in various forms. Now, when we talk about data, I said it's divided into two. We have the numeric or quantitative. When you talk about numeric, you are talking about things you can measure, things you can count, things you can quantify, or we call it numeric or quantitative data or information. That's one. Then when you talk about data, again, it can also be non-numeric, things you cannot really count. Okay, things you cannot measure. They are non-numeric and they are qualitative in the sense that I can just use some symbols to qualify them. This like for income level, for example, high income level, medium income level, lower income level. There are levels you cannot really measure, but you can use some qualities to measure them. Some are non-numeric. How do you measure them? Okay, so data is divided into two: numeric or quantitative, or non-numeric or qualitative data. And each of these are further divided into two each, from what you can see from our presentation. Now, for the numeric, things you can measure, things you can quantify, we have what we call the discrete and continuous. Discrete and continuous data. Now, as I told you, you can measure them, you can quantify them, you can have values for them. Now, when we say discrete, it means numbers that are whole number. You know, when you talk about whole number, no decimal points, like counts, the number of people, number of cars, number of houses. So when you have numbers or counts or measures that are whole numbers, we say they are discrete data. Okay, I want to calculate the number of students doing start 111. That's a discrete. I want to collect the data of this and that. These are discrete. When you get those stuff and they are whole numbers, then you say they are discrete. Now, when we say continuous, what data can we say are continuous data? If I ask you to find the temperature, to measure your temperature, if they give you the thermometer or thermostat, I don't know what they call it now, to use to measure your temperature, you will notice it will give you a value because it's measurable, but you will be having 36.2, 36.1, 35 point that. Those numbers are not whole numbers, so we cannot call them discrete, but we'll call them continuous data. You know, when we say something is continuous, it's in fraction, real numbers. You know, when we talk about real numbers, numbers that are in decimals are said to be continuous. Real numbers, negative, real numbers, positive, real numbers. For example, you may be interested in the height. Find the height of the students doing this course, for example. If you want to calculate height, you know that there are different types of height. You will not have whole number under height. You'll be having decimal values. Okay, 5 point something is 4 point something. These are the heights you will get. So when you have data that fall into that category, you said they are continuous data. Okay, so we've explained the first branch of data, the numeric or the quantitative data that I said are true. It's either they are discrete or they are continuous. Now, the other arm of data is non-numeric or qualitative data. And as I did tell you, for non-numeric, you are talking about data that are not measurable, that cannot be measured, but you can qualify them somehow with some characteristics or some things to make them have meaning, but you cannot really measure them. Okay. For example, if we're talking about sex, you have male and female. They are not quantitative. You cannot measure it. You can only qualify it. Okay, this is a male, this is a female. Okay. When you have such data, they are under non-numeric or qualitative data. Now, again, under this arm of data, you have the ordinal data, you have the categorical data. What do we mean by ordinal? Now, these are some kind of data that you can arrange. They have a kind of arrangement, but you cannot measure it, but they have a kind of ordering. Somehow, you call such data ordinal data. Like, for example, I remember some time ago, they were talking about, who are those in your age group, your age mates? You know what they call age mates in the village. So when you are in the village, they don't talk about, they have age group or age brackets. So when you are in the village, they want to know which age group do you belong to, you know? So those age groups are arranged in order. So like I can remember in my own place now, they will say, okay, who is the most senior in the village? They will go to the age group. All the people in that age group that are in that stuff, they will pick the senior from there. Before they can go to the next age group to pick anybody to lead the village, to be the head of the village, all the people in that age group, the first higher age group, must have all died before they can go down. So there's a kind of hierarchy. There's a kind of ordering in that kind of data. If you have data that are structured like that, they have a kind of ordering. High income, something, medium income, low income, they are arranged a kind of ordering. Then you call such kind of non-numeric data or qualitative data as ordinal data. Data that are arranged in a kind of ordering form or ordering manner. Okay? Now, when we talk about categorical data, categories, you cannot put them in ordering. You cannot make one higher than the other. When you have data that are in category, like sex, for example, is a categorical data. Can either be male or female. These are categorical data. If, for example, you have a column for sex or gender, you know you are going to put male or female, male or female, male or female in that column, that variable. That data you have collected under that variable is said to be a categorical data. If, for example, we have a variable country, for example, for country is also categorical because you can have Nigeria, Ghana, Togo, Cote d'Ivoire, Mauritania, and so on. You can list them under that column. That data is a categorical data. Why? Because it's not numeric, you cannot measure it. 2 is not ordinal, but though it's non-numeric, it's categorical, it belongs to a category. So you have data in that form that are category. Another example could be category like agree, strongly agree, neutral, disagree, strongly disagree. These are categorical data. Okay, and then people can fill in. So you can have these different 4 areas of data for you. Now, I have said a lot here now. I said if you have any question to ask, you can ask me now before I go further. Okay, the absence of no question. Ayola, do you want to ask any question? Okay, so what is a statistic? What is a statistic? Please note that there is no S at the end. Statistics, we have defined that. What is now statistic? A statistic is a quantity whose values or whose numerical values can be obtained from data. Whose numerical values can be obtained from data. Now, a statistics further, if I would explain, is a value that describes a sample. It's a value that describes a sample. For example, I've been talking about average mean because you are used to it. The formula for finding average and the mean or the mean is a statistic. So when you talk about statistics, that you can help you to calculate some values or to describe a data or something, you call that a statistic. Mean is a statistic. Standard deviation is a statistic. Whatever again do you normally calculate? I will mention others which you are not used to, but the ones you are used to, variance, yeah, thank you. Mean absolute deviation, I think you have done that in your secondary school. So all these things are said to be statistic. Okay, so it's a statistic is a value that describes a sample. And then most sample statistics are found with the aid of formulas, which I've said earlier on. For example, mean, median, mode, these are all statistics. Okay, which we are going to be seeing later on and more of that. The last term I would talk about is experiments. Experiment. If we say experiment in statistics, what are we talking about? If I say carry out an experiment, just basically as those in physics, we do experiments. Whether you want to find using resistance and what is this thing now? Current, you want to calculate some things and all that. You know, you go to the lab, you put in all this, your experiments, and then you carry out your experiment. The same thing, those who are in chemistry, we say, okay, we want to do some titrations and some analysis and all that. They join this with that and all that, see what result they are going to get in the lab, in the lab, and then they get something. They call it an experiment. Lab, they do put it under the microscope or do some things, you know, and then do experiments with whatever they have and then get results. They also call it experiment. In statistics, when we say experiment, what do we mean? Now, an experiment is a planned activity whose results yield a set of data. For example, when you are in the physics lab, you do experiments, you get results. You call it experiment. Whether you are in the chemistry lab, you do some titration, whatever, you get some results, you call that experiment. Whether you're in the biological, whatever, you do whatever, you get an experiment. In statistics, anything that you do that gives you data is said to be an experiment. You going to the Third Mainland Bridge, standing there and counting the number of Toyota cars that are passing, that's an experiment in statistics. You are in the Faculty of Science, you are counting the number of cars that are parked at the Faculty of Science car park. That's an experiment. So anything you do, you taking questionnaire, going out and disputing to people for them to fill in the questionnaire and give to you in statistics, that is an experiment. So anything you do that yields results, as they do in those labs I've mentioned, for us, our own result from whatever data you collect is said to be an experiment. So you can go to various forms and other arms. Anything you are doing that is giving you data is an experiment. You sitting down, you know, these days people do online questionnaire, they send questionnaire online and people fill and answer their questionnaire online. That's an experiment. So in statistics, a planned activity that yields result is said to be an experiment. Okay, I think we have done some bits today. We need to, maybe I will end with this one. We talk about data collection. When we say data collection, we've talked about types of data, sources of data, which we are going to look at now, and methods for collecting data. Okay, so let's talk about data collection. You see, one of the first problems as statisticians is obtaining data or collecting data, especially in Nigeria, where we don't really save data. We don't really collect data most times for many of the things that are happening. Okay. If you want to do research now, I've had several students who want to do research on something, but to get those data are not really feasible because we have not been keeping records of what is happening. You can even be shocked that even a whole department, if they tell them, okay, bring all the list of all the students that have graduated from your department for the past 20 years, some department may not be able to get it because they are not keeping records. You understand? So it's a big challenge to us here in the country because our people are not collecting data. So data can be collected directly from the respondents, or you can collect data from an established data bank. This is how we can collect data. It's either you go out yourself, distribute questionnaires, or you go out yourself and ask people questions, or you go out yourself and do some manual calculation yourself to get the data, or you go to established data banks that have those data that you can use. For example, we have Nigeria Bureau of Statistics. They keep data about so many indices or so many things in the country. You have like the CBN, for example, Central Bank of Nigeria. They also keep data about all the financial regulation, financial transactions, many things about financial matters in the country. You may be able to get some data there. You go to the Nigerian Stock Exchange. They also keep data for many years, transactions of the stock exchange of several products and several companies. You can get all that from Nigeria Stock Exchange. Now, when you collect those data, you can collect from them, those banks, established data bank. Then we say those data you collected are secondary data. The one you collected yourself, we call it primary data. Types of data, primary data. This one you collect yourself and you do whatever you want to do. Secondary data are the ones you collect from established data bank like the CBN, like the Stock Exchange, like the Nigeria Bureau of Statistics, or anybody or body of organizations that keep data about things. You can go there. Like some of the hospitals, for examples, they keep record, they keep data of the different patients, their situations, what happened to them, all those stuff. You can have those things already kept in some of these hospitals. You may be able to go there and collect them to use for your work. When you collect such results that are already prepared or data that are already prepared and kept, what you call that is a secondary data. Secondary, because already it has been collected and stored and kept somewhere. But the one you collect yourself, you go from the source, you go around and collect and tabulate. We call that a primary data. Yes, any question? Pelumi, Taiwo, you are
Sir,
raising
please, what
up
is,
your hand.
sir, what is the
Yes,
database? Can you
data,
define database?
database.
Yes, sir.
I didn't mention database. Oh. I said data
I
bank.
know. I know. I just want to know the definition of database.
It's not part of this course now. That's in computer science.
Okay, sir.
We're talking about how you keep data in the drive or a bank, or you keep it in store in the computer or hardware or things like that. That one is a different thing. Okay. Yes, so okay, there are two methods used to collect. Okay, there are two methods used to collect data, which I've mentioned. These are experiments and surveys. Experiment, as I said, you go out, whatever, calculate and all that. Survey is you having questionnaires, distributing it and collecting. So these are the two methods we can use to collect data. In an experiment, the investigator controls or modifies the environment and observes the effect of the response variable. This is common to laboratories where they collect whatever. In the survey, the data are obtained by sampling some population of interest. So various methods that might be used in order to obtain sample data from surveys are also presented below. We have what we call sampling frame. A sampling frame is like a register. A register, if I say, give me the sampling frame in your class, that is the list of everybody in your class, the name, the matric number, the whatever. That's a sampling frame. So if you are carrying out research, you need a sampling frame. Kazim, hello there.
Sir, please, can you please explain the experiment and data, the experiment and survey, sorry.
I said a survey is you going out with questionnaires, distributing the questionnaires among your population of interest and getting the response. In an experiment, you control or modify. You can go out, ask questions. Okay, you can go out, collect the samples. Like I said, counting the number of cars that are going around. That's like an experiment. You get the results. How many cars are parked in the Faculty of Science? You do your calculation and calculate. That's an experiment. Okay, but when you are talking of a survey, you have a template. You have a question, a set of questions. You have a printed out paper. Or maybe if it's e-survey, you have questions already typed and printed into the survey, into the e-stuff, which you now distribute to people to fill and collect. That's survey. I don't know if I've explained the two different for you. And Kazim, I hope it is understood.
Yes, sir. Yes, sir.
Okay, so I think I will end here today, except if you have any question. You can look at the exercises. I'm not sure if we have the exercises. Do we have those exercises at the back of them? Yeah, I think the exercises are there. So you can check that and just play around them. Okay, this should be 1.4. So look at them and see how you can attempt them yourself. Okay, so I will
So will we get the slides for the
mention the
exercises?
course content again. The slide is not a slide, it's a book I'm showing you. So if you get the book, it's a book I'm using. Maybe as we go on, I'm going to be writing. I didn't do any writing today because what we are doing is just a mere introduction. So maybe by next week, I may be doing some writing or something on the board. So I may use my writing pad to do that. Okay, so
please, sir,
yes.
can you share us the textbook? Can you share the textbook with us?
I've told you the title now. If you go to Bookshop, it's a common book. Once you ask them, they will show you. A first course in statistics.
That is because of people that are not living in Lagos. People that are not living in Lagos.
I don't know if you can get the book elsewhere. It was a book. It's a book produced by the department. Can you see it?
Yes, sir.
Yes, sir.
That's how it looks like. Okay, so I will give you the course description or the course contents. We have statistical data, types, sources, which I've mentioned today, and methods of collection. Statistical data, types, sources, and methods of collection. Sources and methods of collection. Then presentation of data. Presentation of data. You have tables, charts, and graph. Table, chart, and graph. Table, chart, and graph. We also have errors and approximations. Errors and approximations. Errors and approximations. Then we have frequency and cumulative distributions. Frequency and cumulative distributions. Then we also have measures of location. Measures of location. Measures of location, comma, partition, 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 dispersion, skewness, and kurtosis. Measures of location, comma, partition, comma, dispersion, comma, skewness, and kurtosis.
Can you spell it?
Allegedly see.
Which one am I spelling?
Who's supposed to give me something?
Skewness and kurtosis.
Skew. You know what is skew?
Head of like my department.
Korede is disturbing us. Skewness SKEW, skew, then ness, NESS, skewness.
The second
Kurtosis,
one.
kurtosis, KUR, KURTOSIS, 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 kurtosis. Full stop. Then you have rates, ratios, and index numbers. Rates, ratios, and index numbers. Okay, so these are the stuff we have.
Okay, thank you, sir.
So in the absence of no other question, we'll call it a day. If there is any other question.
Sir, can we get your number, sir?
Okay, number. I am on. Okay, you know what? Maybe the governors of those doing this course should get across to me. I don't want to put my number, though my number is a public something. If you go on the website, you will see my number anywhere. My number is very easy to get. But apart from that, the governors for statistics, governor for computer, governor for physics, or any other department, you can chat with me on WhatsApp, and then we can form a WhatsApp group, maybe for the course, or perhaps maybe if the governor is here, just send me your phone number, maybe on the chat box. The governor for statistics, who is the person? The governor for statistics, who is the person? Governor for computer, who is the person? Governor for physics, who is the person? Yes. Emmanuel and Young, Obasi, can you answer? I don't know. Are you?
Good afternoon, sir.
Yeah, Emmanuel.
Thank you very much.
Afternoon, baby girl.
It has been enlightening. I raised up
Yes.
my hand to ask a question. The governor of computer science is actually
You're supposed to be
Wumi.
looking at it now.
This girl, Zimalik also is disturbing us. Okay, going on.
So I'm not the governor of my class. She will raise up her hand later. My question is this, sir. If you are giving a set,
Please,
if you are giving a
call
sample,
governor for computer, send me your phone number.
Sir, should I drop it in the chat or I should send it to you privately?
You can send it privately.
Okay, sir.
Those in computer, the governor, have not seen your stuff, so that I can create a WhatsApp group for this course, and then all the informations that we have, I will be passing it to us from there. Okay, Young, why is he raising up the hand?
Sorry, sir. I want to ask that can we have this recording on YouTube?
You can.
Okay, sir.
Sir.
Now, Longe,
Sir, good
is
afternoon, sir.
that your okay?
So I want to ask if this class is also for engineering students.
I don't know. I don't know those doing the course now. Me, I don't have idea. Our computer
Okay, sir.
science class representative. Do we have two people there? Longe, I don't know what the phone number is for.
Sir, you means the question. She will send her number to you.
Computer.
Yes, it's for computer science.
081 3 6 4. Okay, I have the one for computer now. The phone
Sir.
number. I saw, I am assistant course rep for biostatistics. And what of your phone number now?
Sir.
That's marvelous. Yes, Samuel.
Please, sir, how much does the book cost in the bookshop?
I'm not sure again. No, the last time I think maybe it was around 4,000. I don't know how much now.
Okay, sir. Thank you, sir. Thank you, sir.
It's 5,500 naira, sir. 5,500.
Okay, 5,500. Okay. So I've only gotten the phone number of computer. Okay, statistics. Okay.
So I have a question.
Okay. Go on.
Okay. My question is this. If you are given a sample containing, say, 60 elements or 100 elements, and then you are asked to provide the sampling frame of that sample, are you going to list all the elements from 1 to 100?
Yes.
You list them, even if it is from 1 to 100.
Yeah.
Okay, thank you very much, sir. I was thinking maybe
sampling frame involves everything in that set.
Okay. Thank you very much, sir. That was my question, sir.
Okay.
So I have a question.
Okay.
So I want to ask these people that collect data from sensors, can we say those data are primary data?
Data for what?
From sensors. These people that count population.
Okay. And Nigeria census, what do you call it? Bureau or something. No, it's not primary. It's secondary.
But
they have already
counting it is primary too.
They have already calculated it now, so they've already. Sorry, I'm reading. Okay, they are repeating the stuff. Okay, I'm taking care of that one. Okay. Yeah, what I'm saying is that they've already done the data collection. So if you go to them to collect, it's no more primary because they have done all the work. So you going to them to collect is secondary data to you.
Okay, sir. Thank you, sir.
So I've gotten the phone number of computer statistics, data science. Biostatistics is the deputy I got. So I will create a WhatsApp group for this class. And then possibly your governors will now add you people into the WhatsApp group. Then I will also add the other lecturer also, so that on that WhatsApp group, we can be communicating. Yes, I think we are through.
I want to ask you a question.
Okay.
There's a virtual textbook I have. The name is Shom Outlines. Is that book good for
Shom's
the course? Shom Outlines.
Schwam series. This
Yes,
Schwam's. It's
yes,
a textbook.
yes.
It's a textbook now, so you look at it.
Do I still need to buy the other one, or I can use just that one?
Well, normally we will encourage you to get our own because all the things we'll be doing will be from there. And if we are going to give you assignment, it will also be from there. So since we are not using the one you are using, so my advice would be that you should get it. Okay, thank you.
Okay, thanks, sir.
Yeah, Samuel, what is it again?
Sir, are we going to treat sampling techniques? Sir, I'm sorry for so many questions. Are we going to
Sampling
treat
technique.
sampling techniques?
Well, it's not in that course outline. Marvelous. What are you disturbing the class for? Is it here you were doing that? The thing I see there is it's not in the course content. Actually, it's supposed to be taught, but I don't know which. It's a new syllabus we are using now, so
Yes, sir.
I'm not sure where they put it.
Okay,
Usually,
sir.
when I teach the course before, I normally teach it also some sampling methods. But
Yes, sir.
since it's not in this course content now, I don't know if that means I'll be going above syllabus if I teach it. But it's very, very important that you'll be taught. So possibly maybe later on, as you go on along, it will be taught
Yes,
in
sir.
one of the classes also or
Thank you,
courses.
sir.
Yeah.
Thank you, sir. Yes, sir.
Okay, so thank you very much for a good time out. I'm very grateful. So I wish you the best. Thank you and God bless you.
So will the recording be sent?
Thank you, sir.
I will send it
Thank you, sir.
to the WhatsApp group.
All right, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
God bless
Thank
you,
you,
sir.
sir. All right, sir.
Thank
Thank
you,
you, sir.
sir.
Thank you, sir.
Thank you, sir. Welcome.
Thank you, sir.